Hey, welcome everybody to 8.6 part 2. So you're on the back side of your notes sheet, and on this side we're going to talk about the two different types of log equations that you're going to be solving. To start off with, I want to remind you of a property we learned, and that was if I have something like 3 and I take it to the log base 3 of x power, the property was the 3 and the log base 3 are inverses of each other, so they cancel is the kind of simplified way of saying it, and that whole thing would just be equal to x. So the reason I tell you this is if I can make it so I've got a base of 3 and the exponent is a log base 3, that part essentially cancels each other, and whatever is left here ends up being the answer. We're going to use that property in just a second. The other thing I want to show you is, let's suppose I had two of the same logs, so they're both log base b. On the left side it's x and the right side is equal to y. If this part is exactly the same base and everything, that means x is equal to y. So let me show you that with example 3, part A. So what I mean is if I've got log base 3 on this side, log base 3 on this side, that means whatever is here is equal to whatever is there. And a more longhand way of doing it is if I think about taking both as exponents of the base of 3, that cancels out the log as well. The shortcut again is if these are the same, log base 3, it's kind of like they cancel each other. And now I have 5x minus 1 equals x plus 7. And then you just solve it. So when you do this again, as soon as you get to this stage, it's an easy solving equation. So subtract x from both sides. 5x minus x is 4x. Add 1. 4x equals 8. Divide by 4, and x equals 2. Let's try it again on example B. So again, really what's happening is we're going to take both sides as exponents of the base 4, and that cancels both of the logs out, and I just have 5.6 minus x equals 18.4 minus 2.6x. I'm going to go through this faster than I did before, so again, make sure you ask me questions in class. This is me assuming that you are all pretty good at solving equations right now. I'm going to get all of my variables on the right side and my numbers on the left. I end up with negative 12.8 equals negative 1.6 when I combine like terms. Divide by negative 1.6, and I end up with x equals 8. Moving right along to example 4, so the other type of log equation that you're going to see. So what I did before when I took both sides as exponents of a base of 4, that's called exponentiating. And when I do this with logs, I do end up getting extraneous solutions sometimes, so we're going to check our answers each of these times. So here's what I mean. In order to get rid of a log base 5, what I can do is I can take both of these as powers of 5, and what I mean is both sides. So I took the left side as a power of 5, as an exponent of 5, and I took the right side as an exponent of 5. So whatever I saw here and here, I just made the exponent, both sides I made a base of 5. This works because now this part, 5 to the log base 5 power, cancels itself. I just have 3x plus 1 equals, and then actually do 5 squared, which is 25. Go through and solve it at this point. I end up with x equals 8. To check your work, we're just going to take our answer and plug it in for x and see if it ends up giving us a true statement. So this whole statement ends up being 24 plus 1, so 25. And if you need to, type in your calculator log of 25 divided by log of 5, but you end up getting 2. So check, it works. Alright, let's do part B. I want to tell you that when I'm doing this, I kind of like to do a shortcut, and instead of this, in this situation, you know how I rewrote everything? When I'm exponentiating, I often like to just write it here. But just know that what I have just done is I've created 4 as a base and 2 as an exponent. So on the right side, for example, 4 squared is now 16, and on the left side, those cancel. So don't be thrown off by my shortcut, and if you need to write it all out a second time, that's okay. So I end up with x equals 13 for this one. Again, go through quick and check it. So log base 4 of 13 plus 3, plugging it in for x. Log base 4 of 16, well, 4 squared is 16, so yep. Starting with example C, we get to some new things. When I exponentiate, you only want to do that at the very end. As much as possible, I want to get my log statement by itself first. And what I mean is I want to get by itself the log and anything that's locked inside the log. So right now, for example C, only the log of x is kind of locked together. But if I look at example E, for example, I was going to say example E, for example. But anyways, I can't exponentiate, or these are all together log base 5 of x plus 2. So I can't subtract the 2 off. That's locked with the log if there's a parentheses. But here the 13 is not in a parentheses with the x, so the 13 I can move. Let me show you what I mean. All right, so subtract 7 from both sides. 5 minus 7 is negative 2. What I'm trying to say is, in a very longhand way, I can use a 13 in this situation because it's not being logged. It's 13 times the log, so I can divide it off. That is legal. That whole long thing was what I was trying to explain to you. And now, don't be thrown off by the fact that there's no base, because you guys know this. If there's no base and it's log, it's really the common log, so the base is 10. So I'm going to take both things as powers of a base of 10. In my calculator, I'm going to type in 10 to the negative 2/13 power. Don't forget to use parentheses. And you end up with approximately 0.702. Now, I'm going to stop with checking solutions for a little bit until it gets to be more significant with example E and F, just to save us some time. So in case you're wondering, I'm intentionally not going to check the solution for C and D. All right, let's move on to D. Again, I'm going to try to get my log statement by itself, so I subtract 13 from both sides. And in this situation, I also want to get rid of the negative before I do anything here. So to get rid of that negative, I'm going to divide both sides by negative 1. Alright, and now I'm at the stage where my log is by itself. This time it's a base of 2, so I'm going to take both things as powers of 2. So x equals whatever 2 to the negative 4th power is. And that is 1 over 2 to the 4th, if you remember our log or exponent properties, I mean. So 1/16 is our answer for that. It does get a little more complicated with E and F, so I hope that you're still tuning in right now. We're going to now combine our log properties that we learned in section 8.5 with the solving. Here's what I mean. Notice that for example E, I've actually got 2 different logs. We're going to want to combine those. I think we actually even called it combining, but we want to combine those, or maybe we called it condensing. Yeah, we're going to condense those into a single log and then solve it. And that's where that skill comes in that you practiced over and over and over again with 8.5. So think back to your properties, look back in your notes if you need to, try to remember a plus sign. What does that mean? Which property was it? It was a product property, which said if I see that plus sign there, both of these pieces get multiplied together. So now I have 6 times x plus 2 right here. I'll go through and simplify that a little more. So I'm multiplying these together, so I'll just go ahead and distribute that right away. So 6 times x is 6x. 6 times 2 is 12. And that whole thing is being logged. Once I've done that, now it's a statement just like the ones that we did earlier. That means I need to get rid of the log base 5. So I'm going to take both sides as powers of a base of 5. I end up with 6x plus 12 equals, and I'm going to type into my calculator 5 cubed, which is 125, and then I'm going to solve it. 6x equals 113 divided by 6 divided by 6. X is approximately 18.83. Now, let me give you a secret. The only time you're really going to have an extraneous solution, honestly, is when you end up with an x squared situation. So when you have an x squared situation is when it's going to be essential to check for the extraneous solution. In most other situations, you will not get an extraneous solution. If this is a quiz or a test, I would tell you specifically when to check your answer, so you don't have to personally actually know when you're doing it. And here's where our x squared comes from. Look at this. I'm going to try to condense this log statement. And when I try to condense this log statement, my first step is to move my number in front to an exponent. Remember, you do not move the negative sign, only the number. So now it's log base 7 of x squared. That's where my x squared comes from. Everything else I haven't touched yet. And now on this left side, I want to use a property and condense those into a single log. If you think about our properties, I got a subtract sign, so I'm thinking the quotient property. So I'm thinking log base 7 of 3 divided by x squared. And this is okay that I have logs on both sides because remember what we did with example 3. If there is a log with the same base on both sides, if I, for example, take both sides as exponents of 7, the base of 7, I end up canceling that and getting 3 over x squared equals 1 over 3. When you get an x squared, it will be an easy equation like this, where in this situation I actually can just cross multiply. So x squared times 1 is x squared. 3 times 3 is 9. And this is an easy one. Most of you, I'm expecting, know how to solve that. I can just square root it because a square root undoes a square. But when I square root something, I could potentially have 3 in here to make it a true statement, or negative 3. All right, so I've got 2 potential answers, and here's where it gets extraneous. So let's just check this really quick. If I put a 3 in up here, I'm going to run out of space here. So, but I'll try it. When I put a 3 in my calculator, I can type in log of 3 divided by log of 7 times 2, and shorthand, it ends up working. I might have to do this more in class because I totally ran out of space. But actually, let me just go down here a little bit. Okay, I'll just go down here a little bit. Now, when I try to check the negative 3, what happens is I end up with that situation I was talking about at the very end of our notes on section 8.5, which is when I get a negative statement right here. It's not possible because remember, this log statement is right now asking me what power of 7 gives you a negative 3. And it's not possible to take an exponent and get a negative if you started positive. If you started positive, there's no way I can make it negative with an exponent. So that is why that doesn't work. That means that the negative 3 is extraneous and only the positive 3 is our answer. So x equals 3, negative 3 was an extraneous solution. All right, thanks for tuning in, and please remind me in class tomorrow to talk more about this example F here if we need to. I'm probably not going to remember because I'm recording this video about 2 months in advance. Thanks for tuning in. We'll talk to you again soon.